In this tutorial we're going to be taking a look at strings in Turing. Strings are a collection of characters, and to start off this tutorial I'm actually going to look at characters first. So I'm going to create a bunch of variables. I'm going to call them C1, C2, C3, C4, C5, and they are all variables of type char, which is a character variable. So that means it's meant to hold a single letter of the alphabet or a single digit. Basically, it's meant to hold one item that you can type into your keyboard. So I could input these from the keyboard, but I want to be very definite about what they're going to be. So I'm going to use the assignment operator, and you're going to see quite quickly, I think, where I'm going with this. So I'm going to put in, for each of these letters, I'm going to assign it its own character. You might notice, if you're familiar with strings already, if you've used them in another capacity, then you might notice that I'm using single quotes here. And actually, let me just show you a double quote. That's what I would use if I was putting in a string. A single quote is traditionally used to put in a character, and that's common among a lot of programming languages. So I've put in the characters for the word hello. And if I wanted to, I could output any one of these characters. So I could do something like this, say put C1, and if I run that, I end up with the letter H. I can also, using the comma, so the put command with commas let me join items together. So I'll do C4, C5. This put command will actually output the entire word hello. So that's interesting enough, but we're actually interested in looking at strings. But I wanted to illustrate to you the basis for strings is actually this idea of a collection of characters. So I'm going to create another variable called word, and this word is actually a string. And I'm going to initialize this variable, once again using the assignment operator. This time I use double quotes. It's a string, and that means the appropriate way to designate a string is with double quotes. And I can put word, and you'll see I get identical output. The first set is a collection of characters. The second set is a string, but that's also a collection of characters. Now there are some interesting things that I can do with a string, and sometimes I can do those things with characters as well. So for example, let's say I wanted to only output the first three characters of my collection of characters here. So all I did there was I changed my put statement, and if I run that, you can see I get HEL. I've lost the last L and O. Can I do the same thing with my string? Well, it turns out in Turing that I can actually do that same thing. In the same way that I requested character 1, character 2, and character 3 in Turing, actually let's make that even simpler. What about just character 1? What if I just want character 1, which is the letter H? In Turing, the way that I do that is I specify which character I want by putting it in brackets after the variable. So I want to output the string word, but I only want the first character. And if I run this, I get the letter H in both cases. Now let's go back to the example I was about to give. What if I wanted the first three characters? Well, with my characters as individual variables, that's how I would do it. HEL. With Turing, the way that I specify I want the first three characters is I say 1 dot dot 3. And the way you read this is 1, 2, as in 1 up to 3. So the dot dot means start at 1 and then go as high as 3. And if I run that, there I have the first three characters. And I can continue to do this. I could do the last 4 characters this way with the individual characters. I could do the last 4 characters this way with a string operation. And we end up with LO in both cases. Now there are distinct advantages to doing this using the string operations. First of all, I've got all of these variables, and I have to keep track of all these variables. And if I wanted a word that was longer than hello, I would have to add a bunch of characters. Whereas with a string, I can simply change its initialization, and I've gone from having a 5-character string to, in this case, 4, 5, 6, 7 characters. This does not change my code, but in the case of the characters, I would have to adapt my variables and keep up with it. So I'd like to now drop the characters from this example, and we're going to focus exclusively on strings and talk about some of the other things that we can do with them. So this will still work. This will give me the 2nd through 5th characters, which is OODB. So if I run that, I get OODB. So that works just fine. A couple of other interesting things we can get from or information we can get from this word. So I could, for example, what if I want to know how long is this word? That is done using the length command, and then I give it the variable of my string. So I run that. It says it's 7, and we know that. We can count that. That's 7 characters long. I can do. I could put anything I wanted in here. I could actually put an actual string in here if I wanted to. That works just as well. It doesn't have to be a variable. Length, bracket, any string, whether it's a variable or whether or not it's an implicit string, which means it's one we've typed in there with quotes. That would work as well. The word hello is 5 characters long. We can do that. Since this command, length, produces a value, in this case it would produce the value 5, we can actually save that in a variable. So I can create a variable called len string, or actually let's call it len word, since my variable is called word, and that's an integer. And then I could say len word is assigned the value length of, and let's go back to using word. And then I could put len word, and let's go back to outputting the entire word itself. So I run that. The length of the word is 7, and the word is goodbye. If I change the word to something longer, super fantastic. Well, that's a longer word, and if I run my program, that's 14 characters long, and it's made up of all of those letters. So there's an example of making use of some of these values. Something else that's actually quite interesting to do with strings is to look for substrings, which is to look for a piece of the substring. So in this case, let's say that we are looking for, we can look among our letters here, and if you notice, the letter F only appears once in our string. So let's start off by finding out where is the letter F in our string. So I will locate, let's say we'll create another variable called locate letter. And that's also an integer. And you'll see how I'm going to use this in a moment. I'm going to use this with the substring command. So I created my string called super fantastic. And now I'm going to locate the letter, or the location of the letter. That's probably location letter. Location letter. And I'm going to ask for the location of, and the way that I do it is I use a command called index, and I give it the string, and then I give it the substring that I want to look for. So let's say I want to look for everything from, or sorry, I want to look for the letter F. So then I put F there. I actually give the substring as a string. That means I put double quotes around it, not single quotes. And in this case, let me go ahead and I'm going to keep that. I'm going to keep the length of the word. And then I'm going to put the length of the word. I'm going to put the word. And then I'm going to actually put the word at the location of the letter. So we can predict the length of the word is 14. We saw that before. When we put the word, we're going to get the word super fantastic. And what is the location of the letter F? Well, if we count these off, we get 1, 2, 3, 4, 5, 6. So the location of the letter should be 6. Let's put that as a separate output as well. And what value is at that location is the letter F. So let's run this. The word is super fantastic. It's 14 characters long. The letter F is located at the 6th character, and I can print out that 6th character all on its own. To go back and make use of substrings, how about I take a look at, instead of putting the word from the letter F, instead of just putting the letter F, why don't I think about putting everything from the letter F until, now there's two ways we can do this. I'm going to show you both. The first one I'm going to show you is until the length of the word. So think about this. If I wrote this out using numbers, what would it look like? So I'm just going to copy that because I'm going to put it back in. But for now, what if I did this? What if I said, give me the word from 6 to 14? Well, 6 is the letter F, 14 is the letter C, so 6 to 14 should be the word fantastic. And if I run that, that's what I get. Now let's go back to what I had before. Well, what is the value of location letter? Location letter is the location of the letter F in this case, so that's going to be 6. What is the value of len word, or length of the word? That is equal to 14. So this is exactly the same thing as 6 to 14. And I run that, and there we go. I end up with the word fantastic again. So this works with variable values, so long as they actually have the appropriate type of value, in this case an integer, or it works with just raw integer values that you put in yourself. As programs become more sophisticated, we actually want to rely more and more often on variables to contain these things, because then if we make a change to our program, that's reflected later on. So let's say if I changed this to super fabulous fantastic, well, it's still going to find the letter F here, but now it's going to go to the length of the word. The length of the word is going to be longer. And so what am I going to get for my output this time? I will actually get fabulous fantastic, because it picked up the location of the first F and printed the whole thing out. Now there's a second way we can do this whole idea of going to the end of the word, and that would be just using the star, using the asterisk. And so I'm going to give a little bit of visual space there. So this is saying go from the location letter, which is 6, out to the star, which is the end. And if I run that, we get the same result. It goes from 6 to the end. So the star is another convenient way of using basically the length of the word. That's what the star represents in this case. And finally, last thing I think I'm going to talk about with regard to strings, I'm going to drop all of the things I have here for now, and I'm going to have a couple of variables. How about word1, and I'm going to have a variable word2, and both of those are strings, and I'll set word1 to be equal to hello, and I'll set word2 to be equal to goodbye. And actually I'm going to create another variable called join word, which is also a string. And I just wanted to show you that you can actually combine strings. So I'm going to say join word is equal to word1 plus word2. And what I'm going to get from there, so let's, just so we can see what's happening, put word1, put word2. I want you to see that they are separate. And then I'm going to join them together, and then I'm going to put join word. And when I run this, there's word1, there's word2, and I've created a new variable called join word, but that new variable is actually made up of the words hello and goodbye. And if I wanted to, I could, just to wrap things up, I'm going to finish with this, put index join word, and where is the word hello in join word? Put index join word, and where is the word goodbye? And if I wanted to be fancy, or it's not necessarily fancy, but how about put index join word, and I just put the word by instead. So in this combined phrase join word, well, what's the location of hello? The string hello is going to start right at the beginning. That's going to be character number 1. The string goodbye is going to start part way in. So hello is made up of 1, 2, 3, 4, 5. So the capital G of goodbye is going to be character 6. And then where is bye on its own? Well, if the capital G is 6, 7, 8, 9, 10. So my 3 results here should be, the first one should generate the number 1, the second one should generate the number 6, and the last one should generate the number 10. And I go ahead and run that, and you see hello, goodbye, and hello, goodbye as the joined word. Where's hello located? 1. Where is goodbye located? 6. And where is bye located? It's at 10. So there's a beginning treatment of strings. There's more that could be discussed with strings, and I will do a subsequent tutorial on that. But this should give you a good start with using strings. Why do we have strings as collections of characters? Using some of the simple functions that go along with them. The length of strings, substrings, searching strings, searching for substrings using the index command, and the idea of joining 2 strings together. This joining of 2 strings is known as concatenation, and that can also be very useful.